Hi, this is Group 3, and we are presenting you about loan approval prediction using data mining models. And my name is Donkada Harshavardhan, and my co-presenters are Shruti Motado and Akhila Mora. This is the outline of our presentation topics, and we'll go through each of the topic and present you in detail. So let's get to the introduction and answer a few questions. Why loan approval prediction matters? So loan approval prediction is crucial for financial institutions to streamline decision-making processes, reduce risks, and enhance the overall operational efficiency. It enables timely and informed lending decisions, contributing to the sustainability and profitability of the financial institutions. Coming to the next question, what are the challenges in traditional approaches? Traditional loan approval methods often rely on manual assessments, which can be time consuming, subjective, and prone to errors. Additionally, also these approaches may lack the ability to effectively analyze large volumes of diverse data, leading to suboptimal decision making and increased chances of defaults. Now, how does data mining revolutionize the loan approval and overcome these traditional approaches? Data mining transforms loan approval by leveraging advanced analytics and machine learning techniques to extract valuable insights from vast datasets. It enables the automated analysis of diverse applicant attributes, improving accuracy, reducing bias, and enhancing the overall predictive power of loan approval model. What insights can we get from the predictive models? Predictive models offer high insights into likelihood of a loan approval based on various applicant attributes. They can identify patterns, assess risk factors, and provide a quantitative understanding of factors influencing approval decisions. These information empowers financial institutions to make data-driven decisions, optimize lending strategies, and mitigate potential risks. To perform the loan approval prediction, we have utilized the following algorithms: logistic regression, k nearest neighbors, and support vector machines, which we will go in detail in the next slides.
My name is Shruti, and let's start with related work. Fatih utilized machine learning techniques to create a predictive model for loan status approval. Sujata, Gudipalli, and Pushyami explored loan prediction using machine learning and implemented it in a web application. Daninas and Garswa focused on the selection of SVM-based classifiers within the credit risk domain. Henley and Han developed a K-nearest neighbor classifier for assessing consumer credit risk. These references are a few among many that have informed our research. Additional sources are detailed in our full report. Now let's discuss proposed work. Here we'll discuss goal, method, innovation, and application. So the goal, we aim to create a sophisticated predictive model for loan approval using three key algorithms: logistic regression, support vector machine, and k-nearest neighbor, enhancing the decision-making process in financial institutions. Method: our approach employs cross-validation to ensure the evaluation of our model is both thorough and reliable, resulting in consistent predictions across various scenarios. Innovation: we have conducted a novel comparative analysis focusing on how these algorithms perform specifically in loan prediction, a study that bridges a noticeable gap in current financial analytics research. Application: the outcome is a user-centric web application that leverages these insights, providing instant loan approval predictions based on comprehensive applicant data analysis. Now let's discuss system overview. This flowchart presents our loan approval prediction system. It starts with data preprocessing, followed by the application of KNN, SVM, and logistic regression algorithms for classification. The system processes user data and employs logistic regression as the final model to predict loan approval outcomes, which are then relayed back to the user. Dataset. Our dataset source is from Kaggle website, and it is loan approval prediction dataset. The composition of this dataset is as follows. It has 4,269 entries, 13 attributes, including key, loan status for classification. Size: it is of 82,944 bytes, providing a detailed range of financial attributes. Integrity: This dataset is comprehensive and remains as proposed, ideal for model training and analysis. Here you can see visual snapshot of the dataset attributes. Now let's see few of the pre-processing steps that we performed on our dataset. First one is column removal. We dropped the column loan ID to simplify our dataset. Next, we handled null values. We used pandas library to detect them. Next, we did data encoding where we transform categorical data to numeric format for our model compatibility. Next, we did numerical organization where we listed all the numeric columns for the targeted processing. And next, we did outlier management where we identified and removed outliers to maintain data integrity. Here you can also see box plots for outlier detection represented. And next, we did standardization where we scale numerical features to standard normal distribution. After that, we did correlation analysis where we used correlation matrix to inform feature selection and model training. Then we did feature integration where we combined standardized numerical and encoded categorical features. Then we did feature selection where we dropped highly correlated features to improve model generalization. After that, we did class equilibrium where we applied SMOD to balance target variable distribution for unbiased prediction. Here you can also see visual representation of heat map for correlation matrix. Now let's discuss about logistic regression algorithm. What is logistic regression? Logistic regression is a statistical method that predicts the likelihood of a binary event like loan approval. It uses input features such as the number of dependents, education level, and income to calculate a probability score. The approach involves a weighted sum of input features followed by a transformation using the sigmoid function, which maps any real valued number into a value between 0 and 1, representing the probability. Now, why consider this model? We consider logistic regression because it's particularly good at estimating probabilities and making decisions based on these probabilities. It's not only powerful but also interpretable, meaning we can understand the weight or importance it assigns to each feature. Plus, it's a go-to method for any binary classification problems. Now, how is it implemented? Implementation involved several steps: defining the hypothesis with the sigmoid function, setting up a cost function to measure the error, and using gradient descent to minimize the error by finding the optimal weights. We applied cross-validation to assess the model's performance reliably, ensuring it wasn't just memorizing the training data but could predict accurately on unseen data. These are the formulas for sigmoid function, cost function, and gradient descent which we used in our project. Now, let me say a few things about sigmoid function. Sigmoid function is the magic function that lets us get the desired probability as an output. It does this by squishing any value to fit between 0 and 1, as you can see in the figure. So finally, the result of this algorithm is that after choosing the best hyperparameters like learning rate and number of iterations, we observed the model's performance. The best results came from a learning rate of 0.1 and 1000 iterations, which provided a good balance across all key metrics such as accuracy and F1 score. This indicates our model can reliably predict loan status, ensuring it performs well in real-world applications without excessive computational costs.
Support vector machines or SVM is one of the algorithms which we tested for our loan approval prediction application, which leverages Vapnik-Chervonk's structural risk minimization theory. SVM is a powerful algorithm that maps our sample points into a high-dimensional feature space. The primary objective is to identify the optimal hyperplane that maximally separates the two classes in our dataset, which is a crucial step in achieving accurate loan approval predictions. Now let's dive into the decision function that SVM employs for our classification, expressed as sine of HU of x into W plus B. This formula involves the sine function, which is a key element in the classification process. It essentially assigns a class label based on the sign of the argument, As we move forward in our presentation, we'll explore how this decision function, along with the weight vector W, the decision HU of X, and the bias term B, collectively contribute to the effectiveness of our SVM model in distinguishing between approved and rejected loan applications. Now let's understand the optimization aspect of support vector machines and the decision boundary. The optimization problem in SVM is handled through quadratic programming, specifically aimed at minimizing this expression, which is half into W to the power T into W. This mathematical formulation guides the SVM algorithm in determining the optimal parameters of our model. The primary constraint involved in this optimization problem is expressed as yi of u of xi into w plus b greater than or equals to 1. Here yi represents the class label distinguishing between approved and rejected loan applications, and xi is a slack variable. These slack variables play a crucial role in accommodating instances that are not linearly separable. By introducing these slack variables, SVM ensures that the algorithm can effectively create a decision boundary that separates data points into their respective classes. Now, this is the linear SVM classifier architecture. In this depicted figure, the decision boundary is illustrated with approved applications designated as 1 and rejected applications as -1. The objective is to determine a linear decision boundary, essentially a line maximizing the margin between both the classes. Mathematically, the decision boundary is represented by the equation w into x minus b equals to 0, where the positive side is w into x minus b equals to 1 and the negative side is w into x minus b equals to -1. The margin distance is computed as 2 by mod w. The objective here is to learn these weights and bias, optimizing them to maximize the margin from the hyperplane. This concept is also called as hard margin. Now let's get to the advantages and disadvantages of the SVM. So firstly, SVM is very well suited for handling high dimensional data, making it effective in scenarios where the data sets involves a large number of features. Also, SVM proves to be efficient when dealing with complex decision boundaries. However, it's essential to acknowledge the limitations of SVM as well. Scalability to large datasets and sensitivity to the choice of kernel parameters pose challenges. In our project, despite its strengths, SVM demonstrated an accuracy of 62.2%, which is very low. Recognizing the importance of the precision in loan approval predictions, we opted for alternate methods.
Hi, my name is Hakla and I'm going to explain about one of the algorithms KNN. The k-nearest neighbors KNN algorithm is a supervised machine learning technique employed for classification and pattern recognition tasks. KNN assigns a class to a data point by considering the majority class among its k-nearest neighbors in the feature space or by averaging their values. The algorithm relies on measuring distances between data points, employing metrics like Euclidean or Manhattan distance to determine similarity. For this project, we are using Euclidean distance. The parameter k plays a vital role in shaping the model's performance, representing the number of neighbors taken into account during classification. It serves as a balancing act where a small k might lead to overfitting, capturing noise in the data, while a large k may result in underfitting, oversampling the model. Selecting the right balance of k is crucial for achieving optimal classification accuracy and generalization. In predicting the class of a new data point using the KNN algorithm, a series of well-defined steps are followed. Firstly, the algorithm calculates the distance between the new data point and all other data points within the dataset. This distance calculation is based on metrics such as Euclidean distance, providing a measure of similarity in the feature space. Next, the algorithm identifies the k nearest data points to the new data point based on computed distances. These k-neighbors serve as the closest representatives in the dataset. Once these neighbors are determined, a majority vote mechanism comes into play. The class label of the new data point is assigned based on the majority class among these k-nearest neighbors. For example, in a loan approval system, if we are assessing a new loan application, the algorithm calculates the distances between the new application and all existing applications. The k-nearest loan applications are then selected. The loan application status of the new application is determined by a majority vote among these neighbors. If the majority of the nearest neighbors have been approved, the algorithm predicts that the new application is more likely to be approved as well. Now coming to the performance evaluation of all the three models, we are going to use accuracy, precision, recall, and FN score to evaluate the performance of each model. Accuracy is the most common metric to be used in everyday talk. Accuracy answers the questions, out of all the predictions we made, how many were true? Precision Precision is a metric that gives you the proportion of true positives to the amount of total positives that the model predicts. It answers the question, out of all the positive predictions we made, how many were true? Coming to recall, recall focuses on how good the model is at finding all the positives. Recall is also called true positive rate and answers the question, out of all the data points that should be predicted as true, how many did we correctly predict as true? And finally, FN score. FN score is a measure that combines recall and precision. As we have seen, there is a trade-off between precision and recall. FN can therefore be used to measure how effectively our models make the trade-off. So for KNN, we applied different K values 1, 3, 5, 7, and among all the K values, we can see that K equals 7 has highest accuracy 92%. So for SVM, the mean accuracy is 63% and mean precision is 74%. And finally, for the logistic regression, with different learning rates and different iterations, we have observed that at learning rate point 1 and iterations 1000, the mean accuracy of the model is 93% and mean FN score is 93%. So among all the three algorithms, we selected logistic regression to build our model for further prediction. Finally, after building our model, we also developed a web application. So for developing the front end of this web application, we used HTML, CSS, and Bootstrap 5. And for backend, we used Python Flask, and Visual Studio was used to as an IDE. This is the home page of the application with a simple button called Start Prediction. By clicking this button, the user can go to the form where they can actually enter their information. So when the user clicks on Start Prediction button from the home page, the application redirects user to this user information page where user can enter their name, number of dependents, education, whether the user is employed or self-employed or not, annual income, loan amount and loan term, CIBIL score, residential assets value, commercial assets value, and bank assets value. Once user enters this information and click on predict, in the backend, the model runs against the data entered by the user and it predicts the final result of the user, whether the loan is approved or rejected, and displays it in the next page. So this is how the web page displays if the loan is approved for user. It displays user's name and also the status of the loan. There is also a button in this page called home button. So by clicking this button, the user can again go to home page. This is one more sample screen for loan rejection case. This also displays user name and the status of their loan application and also the home button. By clicking the home button, the user can go to home page of the application.
In conclusion, our project seamlessly integrates machine learning algorithms with a user-friendly interface, resulting in a highly effective loan approval prediction application. Logistic regression emerged as the superior choice, known for its simplicity and interpretability, ensuring precise predictions with an accuracy of 92% and an average runtime of 120 seconds. The success of our application is fortified by robust data preprocessing, contributing to overall accuracy and a positive user experience through an easily navigable interface. Now, moving forward to the future work, our project paves the way for ongoing algorithm optimization, ensuring sustained accuracy and model robustness. Future work also includes enhancing pre-processing techniques through modern techniques like principal component analysis for improved model performance. Additionally, we also aim to incorporate external data sets related to economic indicators, interest rates, or regulatory changes for a more comprehensive understanding of the financial landscape. These efforts collectively ensure the continued adaptability of our application. Now, this is the demo of execution, and we are running the script. When we run the script and open the browser, you can see the home page, which contains of a loan approval prediction and the start prediction button. When you click on the start prediction button, the user will get uh, an input page to fill up where he's asked about his personal details and other fields like annual income, loan amount, loan term, CIBIL score, etc. to fill up. Now, when all of these is filled up and the user clicks on predict, he or she will get if the loan is approved or rejected in the next page. Similarly, here we have shown two cases. This one is loan was approved in this case, and in the next case, the loan will be rejected due to a few terms like he's not a graduate and he has a less CIBIL score, and based on the parameters which affects the loan application status. So here, as you can see, the loan is rejected for the user.